Welcome back to Section 5. This gets into the second half of Chapter 3, and by second half I mean the second 2 sections out of 6. It's where they split it. In this section, though, we are going to be looking in 3 dimensions. Never mind. Today we're going to kind of look at how do we graph in 3 dimensions and stuff like that. And then next time, we will be looking at solving systems of equations in 3 dimensions. That's where it gets really exciting. So, our learning targets for today: I can graph points in 3 dimensions, and I can graph linear equations in 3 dimensions. So when we're graphing in 3 dimensions, things are a little bit different, and I tried to think, how could I put this right in here, and I couldn't quite come up with it, so here we go. So for graphing in 2 dimensions, we just need our coordinate xy axis. In order to graph in 3 dimensions, we need some extra stuff. The first thing is you need to get 3D glasses. They should be behind your device, whatever it is you're using. You're using your phone, check behind the phone. You might have to take the back off to really get at it, but they should be there. Whoa, you guys look almost real. Crazy. Now, all right, the 3D glasses aren't actually going to help us graph in 3 dimensions, but how cool would that be? What we do need, however, is we need a third axis. The third axis goes through the origin, and it just comes straight out at you, like that. And so, to graph a point, let's say we have the point 3, 2, 1. I'm going to go out this axis, which is the x-axis. I'm going to go out 3. I'm going to go over 2 on the y-axis, and up 1 in the z-axis. I'm going to put a point right here. Chalk's not working. Hold on. Oh. Different chalk. So the point was right about here. So I get cheap chalk. It doesn't write in the middle of the air. Chances are your pens don't either, nor do your pencils. And so that poses a problem. But in addition to not being able to write there, could you imagine trying to turn in an assignment with points floating out off the paper? That would be pretty crazy. I've actually done it. I have it on my wall. You can stop by and see it. So that's one problem. Another problem is, what if I had a negative x value? It would be on the other side of my chalkboard. I would have to go out the door into the English classroom behind my wall and put a point in her error. And she has told me, made it very clear, that she does not want me to do that. She wants her classroom to be pointless, and I will respect that. So, how can we fix this problem? We take this axis, it's pointed straight out at you, and we are going to bend it into 2 dimensions. And so that third axis comes down like this. And when it's drawn, it looks like that, where this is the stuff on the outside, this is the stuff behind the axis, behind the board. So that would be looking into it. And so that's why we have these crazy axes that look like this. Know that this is coming out at you, kind of like the yardstick here. It just pointed out. And so with that, we will see how we can graph on this 3-dimensional set of axes. And so, to graph points in 3 dimensions, we're going to start with our axes, which looks a lot nicer than what I have on the board. And then we need a point. In 2 dimensions, we have ordered pairs, because it takes 2 numbers to make it. In 3 dimensions, we have ordered triplets. That just means we have 3. And it's alphabetical, X, Y, Z. And so, we're going to go to plot this point. We're going to go 3 in the X direction. So we're going to start at the origin and go out 3. Then we're going to go 1 in the Y direction but we're not going to do it from the origin. That's good to get your distance. We're going to do it from the end of our first path. And then we're going to go 2 in the z direction. We have our distance, but we're going to be doing it from there. And then the point goes at the end of that. Now you can make the trails, but that's not part of the graph. The only part of the graph is the point. Now is that the only point that could be graphed right here on this graph? No, not at all. 0, -1, 0 looks like it would be right about there too. And so there's lots and lots of points that could be there. But remember, it's not right here. If the origin is the center of your screen, it came out at you about 3 inches, then it moved over an inch, and then it went up 2 inches. It's just floating above your screen. That's where their 3D glasses come in handy. So let's look at another one. -5, -1, 3. We start at the origin. We go -5 in the x direction. That's this diagonal one. And then we go -1 in the y direction. And then 3 in the z direction. And we can put our point right there. And so we have 2 points plotted on this axis, set of axes. And so we have, we're graphing points in 3 dimensions. This is less of a science, more of an art form. And your points might look a little bit different than your neighbor's points. That's to be expected. Graphing linear equations in 3 dimensions is actually a little bit easier. Now, linear equations, people think, oh, that's going to be line. Linear does not mean line necessarily. It is 1 dimension less than the space that we're in. So in 2 dimensions, it becomes a 1-dimensional line. In 3 dimensions, it becomes a 2-dimensional plane. So to graph linear equations in 3 dimensions, we're actually graphing a plane. So let's start out with our axes and get an equation. 2x plus 5y plus 4z equals 10. The easiest way, and the way that I strongly, very, very strongly recommend you graph these, is by graphing the intercepts. The intercepts, we're going to have one value and a couple zeros. So the x-intercept is going to be something, comma 0, comma 0. The y-intercept is 0, comma something, comma 0. And the z-intercept is 0, comma 0, comma something. So for the x-intercept, if we make y and z 0, 2x equals 10, so x equals 5. For the y-intercept, if we make x and z 0, 5y equals 10, so y equals 2. And if we make x and y 0, 4z equals 10, and so z would equal 2.5. Now we can graph these 3 points. Graphing on the axis, graphing the intercepts, is much easier than graphing the points in space, because we only need to move along one of these lines. And so, like the point 5, comma 0, comma 0, we go out 5 and put a point. 0, comma 2, comma 0. We can go 2 in the y direction and put a point. And 0, comma 0, comma 2.5. We go 2.5 in the z direction and put a point. Now we're going to connect the dots to make a triangle. And I have the middle shaded in. You don't have to shade in the middle. It can get kind of funky looking when you're drawing it. But this is the representation of the plane in 3 dimensions. It's not just a triangle. It keeps going in every direction. But if I shaded everywhere, the whole thing would be shaded and you wouldn't be able to see a thing. Now, and this isn't just a triangle. It's not flat, remember. Your origin is on your screen. These 2 points are on your screen. This point is about 5 inches straight up from the origin. So if you put your finger about 5, well, maybe not 5 inches, but 5 units, however far that is for you, you put it straight up from the origin, and your plane is going to be going from that point to these 2 points. So it kind of angles back that way. And that's graphing linear equations in 3 dimensions. It's probably a lot easier than you thought it would be. We're just going to graph the 3 intercepts, draw a triangle, and call it good. And so, again, it's more of an art form than an exact science, and we'll be solving equations like this next time. Thankfully, we don't do that by graphing. And so, until then, happy mathing, and I'll see you next time.